All right, welcome back, everybody. Where were we? We were working in 3.2. What was the name of the section? Logarithmic differentiation, I think it is. Yep. Differentiation. And as a quick reminder, since it's been a few days, we had the derivative of the natural log of x is 1 over x. And the derivative of when it's a different base, log base b of x, is 1 over x ln of b on bottom. And we found those, this one doing the definition of the derivative with that good old limit as h goes to 0. And the other one, we use log properties based off of natural log of x. We did a couple examples, but we're going to do some more. So the example we're going to start with here is let's find the derivative of the natural log of the absolute value of sine of x. So we could do like a substitution here. We could say u equals sine x and do that. Do like a chain rule here. So like if f of x equals natural log of x, we have f of u right now. So if we took the derivative of f of u, we have f prime of u times du dx. The question is, what does the absolute value do? So absolute value of u, if u is greater than or equal to 0, it doesn't do anything, just equals u. And the absolute value of u equals negative u if u is less than 0. So let's take a look at both options. Just doing ln of u. If I did the positive, I'll call that A and call this B. If I do A, I'm just doing the natural log of u without absolute values, and we saw that was 1 over u. We have that list up here. And we still haven't done the du dx part yet, but we're making sure we know what the first part equals. If we do the negative version, we're doing d dx of the natural log of negative u. So doing the chain rule, we would put that on bottom.
So David.
And then we take the derivative of the inside.
So David, sorry. The light is too strong, and yeah.
Yeah, when you cleared your voice, I looked up and saw that it was too bright. Thank you. And the negatives cancel, and we're still 1 over u. So absolute value didn't do shit. It does address the fact that we can't stick something negative in natural log though. Okay, so it fixes the problem with natural log. But that means we can do the derivative here. We have natural log of u. Doing the derivative of natural log of u. Absolute value of u is just 1 over u. And then du dx. Well, 1 over u was 1 over sine x. Du dx is what? Cosine. So that's cosine x. So we have cosine x over sine x. Or cotangent x. Everybody got a little bit of a feel for natural log, maybe not mastered it, but. When we have the natural log, we just take the inside, put it on bottom. In general, I could have skipped doing the U substitution, then chain roll. So chain roll approach without putting in U. Doing derivative of natural log of sine x. It's gonna equal 1 over sine x. And then we do the derivative of sine x. And we're back to cotangent. The more practice you get doing without U, you'll find that you go quicker. U is sometimes very necessary. Doing the substitution is very necessary because you just can't wrap your head around it, kind of thing. But if you do it with U and then practice it without U, you'll get fast on some stuff. All right, you guys ready for the real power of logarithmic differentiation? This is the boring shit. Actually, if you need to have longer, say something.
Wait. Let me go down.
I did go back.
Go down. Oh, okay.
It's on the
Thank
fucking
you.
screen, bro.
Thank you.
Better out than in. So my wife gets mad at me if I fart in public. At a restaurant, she gets really mad. Because no one can hear it generally at a restaurant. She'd be doing it, make a noise. But she knows. I must make some of my face changes. I stop smiling for a second. She fucking knows. And then she gets mad at me if I fucking burp. I'm like, you gotta take your pick. If I don't burp, the gas is still there. Which direction you think it's gonna go? And she has no comment about that. Alright.
Sleep on the couch.
The couch is like, yeah, it's alright. Alright, so. Find y prime if. Y equals x squared over or times the cube root. Of 7x minus 14. All over 1 plus x squared, that to the 4th power. Who wants to do the quotient rule here? Because the quotient rule is gonna have some chain rule and some product rule. What? 7x minus 14. So let's use some stuff here. I hope you like this. What we're gonna do is I am gonna take the natural log of both sides. So we take the natural log. And later on, we have to undo this. But taking the natural log, once something's in the form of a natural log. We can use properties of natural log. To separate this beast into a bunch of stuff. When things are multiplied together, it becomes addition. So I can do this as natural log of x squared plus natural log of the cube root. I'm gonna write the cube root as to the 1/3 power. And then when you have division on natural log, it turns into subtraction on the outside. Now we can bring the exponents down. So you just bring all the exponents, put them out front. This is some cool shit. Cause the quotient rule on that sumbitch was gonna be a pain in the ass. You have a product with a radical up there. It was just gonna be a clusterfuck. And now we hit that bad boy with ddx on both sides. So the derivative of the natural log of y is 1/y. And then dy dx. We're doing that implicit differentiation. The right side. The derivative of the natural log of x is just 1/x. So a fun thing I noticed while grading you guys' exam. A fuck ton of you are treating a constant in front like a product rule. Don't do that, just pull the constant out. Take the derivative of just the natural log of x. Let me finish this line, I'll show it to you, see what I'm talking about. Derivative, we got 1/3, we're doing the derivative of natural log of 7x minus 14. That just puts that on bottom. And then we take the derivative of the inside, which is 7. Well, a bit of a chain rule right there. And then we have -4 times. Natural log is 1, just takes the thing and puts it on bottom. And then we take the derivative of the inside, the derivative of the inside is 2x. Alright, so let's clean that up, see what we got. I'm gonna multiply the y over. Just putting it out front. And cleaning this up. We got 2/x. Plus 7/. I'll leave the 3 factored out for now. And I've got 4 times 2x on top, which would be 8x. And 1 plus x squared on bottom. You know, if we take this 7x minus 14 and treat this as times 7 times x minus 2, we can reduce this a little bit. So the sevens will cancel. And that middle term will just be 1/3 times x minus 2. And now we're almost done. So y prime equals y, but y was x squared cube root of 7x minus 14 all over 1 plus x squared to the 4th power multiplied by 2/x plus 1/3 times x minus 2 minus 8x over 1 plus x squared. That's why. Fine. Now the answer is messy. But we knew it was gonna be messy just looking at it from the start. The steps to do this were substantially easier than trying to do the quotient rule and keeping up with the product rule and the chain rule. And oh my goodness, that was just gonna be a clusterfuck. Now, what I was talking about earlier, as what I was seeing on the test. If we take the derivative of some constant times f of x. I want to show you what some of you are doing. And then some of you are getting it right, but it just takes you extra work, and some of you are just getting it wrong. Some of you are treating this as a product rule of do the derivative of c and then multiply it by f of x. And then leave c alone and then do the derivative of f of x. This does work. But the derivative of a constant is 0. And the derivative of f of x is f prime of x. So this just turns into c and then f prime of x. Which is the same thing as just pulling the constant out front. That's c times ddx of f of x. So don't do it, treat it as a product rule, just constant, the coefficients can come outside. That was a common enough that I want to say I probably saw at least somewhere on about 40% of the tests. At least on one problem. Alright. You guys ready for another one? Are we having fun yet? You smile, you haven't seen what, probably haven't looked ahead to see what's in 3.3. So let's find the equation of the line. Tangent to the curve. Y equals x to the x power at x equals e. So the equation of the line is, the generic form is y minus y1 equals m times x minus x1. If we're using the derivative to find the tangent line. This is gonna be m tangent. And I'm gonna say evaluated at x1. So f prime at x1. And then times x minus x1. I'm gonna say about 20% of the tests took the derivative. And just plug that in with like the derivative on that problem that we had on the test was 9x squared. And you're supposed to do it x equals -1, but they just put in 9x squared. And they didn't do the -1 in it. So. We're gonna deal with that, but first we gotta take the derivative of this. And it's kind of almost universal, if you've got an x in the exponent. Or a variable in the exponent, you want to do natural log on this. Because natural logs allow us to pull exponents down and get them out of the exponent. And it's the only property in mathematics that does it. It's really, really a useful trait. So this becomes x ln of x. And if I do ddx here on both sides. There, 1/y, and then dy dx, we gotta do, it's implicit there. Here we do the derivative of x, I'll write it out. Plus x times the derivative of natural log of x. That last little part you can skip to this line. When you're comfortable in doing it correctly. This is 1 times natural log of x. Plus x times 1/x. So if you clean that up, that's just natural log of x plus 1. We still have the y, so I'm gonna multiply both sides by y. And then I'm gonna put the what we had for y back in. So this will give us the slope of the tangent line at any point on the curve. We want to find it at E. So if I evaluate at E. It gets ugly, but at least it's doable. This is E to the E. Which sounds weird. And then times natural log of E plus 1. What is the natural log of E? That's just 1, right? So we got 1 plus 1 is 2, 2e to the E. That's my M tangent. Evaluated at E. So now I've got M tangent, we've got x1, all I need is y1. Y1 is just plugging in E. And we have the E's listed twice, so it's just that. And our equation ends up being y minus e to the E equals 2e to the E times x minus e. There's a lot of E. Like crazy, right? And if you want it, you can clean it up. Plus e to the E. And I would probably factor out the e to the E. And write this as 2x minus 2e. That way there's less ease. And it doesn't seem so fucking batshit crazy. Did I fuck something up?
Well, where did the end E go? The plus E to the E? Gives me-
That's an excellent question. It's right here. You didn't see it? Think about that. So that went there, and that one's there. Maybe I'll write that a little bit cleaner so that it doesn't look like. An amateur wrote it. I really do know what I'm doing, even though it doesn't always look like it. And that'll be it for 3.2, so I'll stop this and make this 2 videos.